I frequently see something that I really, again, really hate to see because I kind of mentioned it before, because I really have to penalize pretty harshly. And I really hate to do that. But if you make a table, and there's nothing wrong with making a more extensive table, except that I want you to be able to graph this by knowing what it is and just using this brief table. Extensive tables do you no good if you don't know what x values to use. And as soon as we start translating and stretching these functions, unless you understand the translations and so forth, you won't know what x values to use. So there are many reasons that I want you to use a very brief table. Okay, well, what's very, very wrong is to make this table, and there's nothing at all wrong with this table, other than it's not really the way I want you to graph the thing, but otherwise nothing wrong with it. And these points, which are all valid points on the graph. Of course, you understand this is -1, -1, this is 1, 1, so here's 2, 1/2, -2, -1/2, etc. I often see students who will make that graph and then connect these with a point here and then turn around, so they go through x equals 0, come up here and turn back around and go down here. Okay? Now that's wrong on many, many levels. It's wrong on the level of 0, 0 isn't even a point on this graph, so it's totally wrong to go through 0, 0. When x is 0, there's no point on the graph, so it's completely wrong to have a graph that passes through the y-axis. Also, if you extended this, let's say to -3 or -4, you'd get you know, the points I graphed here don't even necessarily correspond to the points I put here. I've got an extra point in here. I've got 1/2 -1/2 -2, and I've got 1/2 2 that I didn't put on my graph. Okay, I kind of implicit. Of course, I know those points are there, but let me label them. Okay, 1/2 2, -1/2. You probably can't read that, -2 right here. Okay. If I went to 1/3 3 and 1/4 4, then the graph would go up higher than this one, and I'd have to go to even greater lengths to manage to turn around in the little space I have to come down here to -4 and then come back up. And of course the graph wouldn't look like this one anymore. It would look like something a bit different. And the smaller the number you put in here, the further you have to go, and the more extreme has to be your attempt to get back down through 0 and to connect this point with this point down here. Okay? And the resolution to that is simply that the graph does not go through the y-axis. What happens when you get to the y-axis is that x changes its sign, changes from negative to positive. So you're going down here, you're approaching -infinity. You cross the y-axis, and now all of a sudden you're up here at coming down from a value that approaches positive infinity. Okay, so you really want to be sure that you understand those characteristics of this graph, because they're also very important for understanding rational functions, which is something people are having a lot of trouble with at this point.